Okay, now we'll talk about the second part of section 10.5, which is the moment of inertia for various shapes. Let us now see for a point mass. The dimension of this mass is just a point. It is not extended mass. So for this mass, it just has a position vector r. We have mass 1 with r1 is equal to 0. We have mass 2 with r2 is equal to r2. And this system is rotating. Now to find the total moment of inertia, I is equal to the moment of inertia for the first body, the moment of inertia, the second body, plus the moment of inertia of third body, fourth body, if exist. And the moment of inertia in general, as we said before, is the mass multiplied by r squared, okay, for a point mass. But r1 is 0. So the moment of inertia 1 is equal to 0 plus the moment of inertia for the second body, which is m2r2, and we don't have any more bodies, so just we have the moment of inertia for this system is m2r2. What if we have extended body, not a point mass? It is another mass like this one or this one, okay? It is not positioned at one point. Look at here. For this mass, we have, inside this mass, we have many position vectors. We can't put one of them in the formula. So it is more difficult to compute or to find the moment of inertia for extended bodies. Okay? It is not simple as the moment of inertia for a point mass body. For these bodies, we have in table 10.1 page 316, we have about 10 uniform shapes body, and their moment of inertia formula is given. You don't need to carry them in the test. We will give you them. You need just to put the numerical values and to calculate what is required from you. For example, for a hoop or cylindrical shell, the moment of inertia is mr squared. For cylindrical solid or disk, it is half mr squared. You have also solid plate, you have sphere shell, also you have rods, and you need to know the position vector from where. Sometimes the origin at the edge of that rod, for example, or cylinder. Sometimes that the rotation is around a point at the center of that object. Let us take a simple example. If the mass for each one of them is 2 kilograms, and the radius for the spherical or cylindrical things is 2 meters, and the length or the width for these shapes, the solid plate or the rods, is also 2 meters. Okay, we need to find that the moment of inertia for each of them. For the hoop, cylindrical shell, if we put the mass 2, the radius 2, then the moment of inertia is 8 kilogram meters squared. Look, the mass is 2, but the effective mass of rotational motion, if the axis of rotation is in the center of that cylindrical shell, then the effective mass is 8, not 2. For a solid cylinder is 4. For a solid cylinder but rotation around an axis passing the edge of that cylinder is 12, and so on. You can see here and you can compute the moment of inertia for each shape if you given the mass and the dimensions of that shape. And you need to know the axis of rotation is passing from the center of that shape or from the edge of that shape. It is just simple. You need to solve some examples. Thank you.